Hello again. This is the second video about the unit circle. And this video is going to focus on measuring the unit circle in a different way. And that different way is known as radians. Okay? Radians can seem kind of complicated. They definitely look complicated if you just look at them from the outside. But really the radian is just related to the circumference of the circle. Okay? If you're good at fractions, all right, plain old like pizza pie fractions, radians are not that big of a deal. And if you really break it down and think about what a radian is and what it represents, this is not going to be nearly as hard, okay, as it would be if you just tried to straight up memorize it. Okay? So remember in the last video I told you that the radius of a unit circle was equal to 1. So if I wanted to do the circumference of a unit circle, I would do 2 times pi times 1, which is really just 2 pi. Okay? So we are going to measure the circle in a different way. In the last video, we broke it up into degrees. We said this was 0 degrees, and then we went 45 and 90, and, 225 was down here, 210 was down here. Okay, so you can break up this circle into pieces that are measured in degrees. You can also break it up into pieces of the circumference, which are known as radians. So that's why I went ahead and showed you how to find the circumference of this circle. So now we're still going to call this sort of our home base. This is going to be 0 radians. Okay? And if I were to walk around the entire outside of the circle, that would be a length of 2 pi because we just found that the circumference was 2 pi. So instead of calling this 360, now I'm going to call it 2 pi. So now, if this entire distance is 2 pi, what would the distance be if I only traveled half of the circle? Well, half of 2 pi would just be pi. Okay, so 1 pi is over here where the 180 is. Okay, so if from here to here is pi, and I were to cut that in half again, that would give me, that would be right here, and that would be half of pi, otherwise known as pi over 2. Okay, which is pi cut in half. So if I were to count by 1/2 pi, so here's half a pi, here's a whole pi, this would be like 1.5 pi's down here, and then this would be 2 pi's. Okay, 1.5 pi's, by the way, we would say 3 pi over 2, because 3 over 2 is equal to 1.5. The other way you could think about it that's helpful to some people is this would be like 0 pi over 2. This is 1 pi over 2. I could technically write this as, and I don't know if you want to clutter up your diagram with this, but I could write this as 2 pi over 2, because 2 over 2 is just equal to 1. Then I would have 3 pi over 2, and then 2 pi is the same thing as 4 pi over 2. Okay? So 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, so each wedge of my pi is equal to pi over 2. Okay? What if you take a half, because this right here is defined as pi over 2. What if you take half of something and split it in half again? Well, you would end up with a quarter of something. So that 45-degree mark from earlier is like half of a half, or pi over 4. Then this would be like 2 pi over 4, because here's 1 pi over 4, 2 pi over 4. And of course, if I were to write that as 2 pi over 4, 2 over 4 reduces to 1/2. That makes this 3 pi over 4. And this one I could also write as 4 pi over 4, okay, which again would just simplify to pi. So then my next halfway mark would be, hopefully you're guessing it, it would be 5 pi over 4. Then another one would be 6 pi over 4. The next halfway mark, this one would be 7 pi over 4. And this last one could also be written as 8 pi over 4. Okay, so each one of these wedges of my pi is a pi over 4. So this is a pi over 4. This would be 2 pi over 4. Boom, boom, boom. That would be 3 pi over 4. Boom, 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 boom. That would be 4 pi over 4. Okay, and on and on and on. Now, just to mention, I throw these extra things like this, like 2 pi over 2, 4 pi over 4. Down here I called this 6 pi over 4. I put those measurements in to make it make sense in terms of the rest of the measurements, but you won't ever actually see me refer to this as 2 pi over 2, because the simplified version of that is just pi. So really, like this and this, you're not really going to need to know those. I just want to make sure that it makes sense. As you're counting around the circle, you can just count 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on. Okay, but remember that the simplified version of the fraction is what you really want to stick with. Okay, I'm going to move to a clean unit circle for a second. You keep drawing on your same diagram. Okay, but I want you to be able to see the circle being divided up in a different way. Okay, so last time we were cutting the circle in halves and quarters and eighths. So we started with one whole circle. We cut it in half, so we had just the top half. We cut that in half again, so we just had a quarter of the circle. Then we cut that in half again, so we only had that much of a circle. Remember, so this was pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on. I'm going to go ahead and put these markings back in, just my corners. So this was 0. This was pi over 2. This is pi. This is 3 pi over 2. And this was 2 pi. Okay, again, knowledge of fractions here is very helpful. This time I'm going to take that circle and break it up on these markings. Okay, so now I'm not using the halfway marks, but I'm using all of the other marks. And that actually takes pi, which is half of the circle, and breaks it up into 1, 2, 3, 4, 5, 6 pieces. Okay, so I'm not looking... Imagine that this whole bottom half of the circle was gone, and I was just looking at pi itself. Okay, pi is half of the circle, which I know seems weird. You want to think like one whole pi is one whole circle, but pi is actually half the circle because the whole circle is 2 pi. Okay, so this right here represents pi, and when I drew these blue lines in, and I guess I should actually have a blue line here too, that cut pi into 1, 2, 3, 4, 5, 6 wedges. So that would make this pi over 6. It would make this 2 pi over 6. Pi over 2 is really the same thing as 3 pi over 6. Then this would be 4 pi over 6, 5 pi over 6. And pi is really the same thing as 6 pi over 6. Okay, so now counting along those other markings, I'm using every line except the 45-degree line, except for this. Okay, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay, now let's go to that other half of that circle and keep counting that way. So if we left off at 6 pi over 6, this here would be 7 pi over 6. Keep changing which way I'm doing my fraction bar. I'm sorry if that bothers you. 8 pi over 6. 3 pi over 2 is really the same thing as 9 pi over 6, because 9 over 6 would reduce to 3 over 2. This here would be 10 pi over 6. This would be 11 pi over 6. And 2 pi is the same thing as 12 pi over 6. Okay, so when I divide on those other lines, I'm counting in sixes. I'm counting in 1/6 of pi. Okay, because that's what I'm breaking pi up into. Okay, now there's some of those in there as I was going around that could simplify further, right? Like up here, 2 pi over 6. Well, 2 over 6 reduces to 1/3. So 2 pi over 6 could actually be written as 1 pi over 3. Okay. Over here, 4 pi over 6. Well, 4 over 6 reduces to 2 pi over 3. Okay. Again, here, 6 pi over 6 would reduce to just a single pi, or 6's would cancel, which is why we left that in there. 7 pi over 6 is good. 8 pi over 6 would reduce to 4 pi over 3, because 8 over 6 would reduce to 4 over 3. 10 pi over 6 would reduce to 5 pi over 3. And then, of course, here with the 12 pi over 6, 12 over 6 reduces to 2, so that would just be 2 pi. Okay? So the big takeaway for radians is this. When you're comparing radians to degrees, there's some equivalencies that you should probably know. 30 degrees, which were those blue lines that we wrote in, is the same thing as pi over 6. Okay. 45 degrees is the same thing as pi over 4. 60 degrees is the same thing as pi over 3. Okay, because remember the 60-degree mark was this one right here, and that's pi over 3. And then if you were to count by 60s, this was pi over 3, this was 2 pi over 3, this would be 3 pi over 3, and you can count by 60s all the way around. 90 degrees is pi over 2. 180 degrees is pi, and 360 degrees is 2 pi. Okay, so those are sort of the basic ones that you need to know, the conversions. And then everything else you can sort of base on those values. If you have a pretty good understanding of these, you can usually assemble the rest of the circle. I'm going to take a second and fill in one nice clean circle here with all of the radian measures so you can get a big picture of what the whole thing looks like when you're measuring in radians. Okay. So here is a copy of a unit circle with all of the radian measures filled in for all of the different angles. So really remember pi over 6, pi over 6 really just represents a 30-degree angle. Because if I were to draw this line in, this angle would be 30 degrees. Okay, that's really what this is saying. Okay, pi over 3 represents a 60-degree angle because this angle would be 60 degrees. Okay, and so on. So that's how a radian is equivalent to a degree. Well, radian isn't equivalent to a degree, but that's sort of how they match up. That's how they correspond with one another. And again, that all comes from the fact that the the circumference of the circle would be 2 pi. So I'm just taking that 2 pi and breaking it into chunks. Okay? Basic fractions. So to look at a diagram like this, I know it looks very overwhelming, and for you to think, gosh, I have to know all of those measures. It seems like a lot. But if you can replicate that process that we just went through, where we cut things in half and then cut them in half again, you really shouldn't have any problem counting your way around the circle. Okay? Take a second, make sure you've got all of this filled in and finalized before you move on to the next video.